Just wanted to speak a little about the origins of the geodesic longitude and latitude system that we find ourselves in. More specifically, I was considering exactly how they determine the longitude and latitude lines that mark out the globe. Of course, it applies to the spherical nature of the globe, and I believe that we figured it out and the implications thereof. First question, did they use the stars to measure the Earth? Astronomical determinations of latitude and longitude were used to measure the Earth by observing the stars. By observing the positions of the stars in the sky, astronomers can determine the latitude and longitude of a specific location on Earth. This method relies on the fact that the positions of stars are fixed relative to each other, allowing astronomers to establish a reference frame for measuring the Earth's coordinates. However, I think it is important to ask the question, why are we referencing anything in the sky to determine the shape of the Earth in the first place? Does it not seem possible to measure and mark longitude and latitude lines based on the ground and topography alone? Why would we need to invoke any alignment or symmetry to the celestial procession at all? I know that it is a common practice in geodesic surveying to make corrections according to the celestial sphere, and that also struck me as very odd. So I decided to take a good look into the origin of the longitude-latitude system that we depend on without even thinking about it so much today. Let us take a moment to explore the mainstream story of the origins of latitude and longitude. When were latitude and longitude invented? Latitude was discovered about 600 BC, according to Wikipedia, and longitude in about 1736. Knowing latitude and longitude makes it easy to know where you are on the Earth, because you're in a geodesic coordinate system that's determination by longitude and latitude. But working them out hasn't always been as easy as it is now. Latitude is technically easier to work out because it has a direct correlation with the sun or the stars. The Polynesians, the Phoenicians, and many other ancient seafaring groups all worked out latitude and used it in the same way. Just to briefly interrupt our historical monologue here, just to consider, it seems many people who are familiar with latitude were using it effectively, but it also seems that no one had a real specific need for longitude at all, which is very odd until very recently. And it raises more questions than it answers, because if you look up the historicity of longitude on Wikipedia, you come across a Greek named Hipparchus, who invented the concept of longitude 2,000 years before anyone would need it for any reason. So he developed the concept for longitude 2,000 years before the first man would need it. That seems odd. Also full of details about him discovering other various aspects of heliocentricity, foundational things like precession, eclipse tracking, spherical trigonometry entirely. So it seems we have a similar situation as the person who invented the globe in 150 BC before anyone made one or referred to it in any way all 1,000 years later. A little bit suspicious. But we can leave that investigation and topic for another day. Let us return to our brief historical interlude. So if you know where the sun is at noon, or if you know where Polaris, the North Star, is, you can generally work out your latitude. This is because Polaris specifically has a direct latitude elevation angle relationship. Its elevation is determined by its latitude. We've discovered that the latitude was actually plotted directly because of elevation angles to Polaris. So the general calculations were only useful. All the other navigation methods to those that the people possess. So it's only useful in the general sense when you have the other skills to determine your position. If you wanted to know your latitude more precisely, it was very difficult to do. Again, interjecting in the historical narrative a bit, if we consider that longitude was a relatively recent invention, and our predecessors had a very different interpretation of how to use the celestial heavens to navigate the Earth, it does make sense that the relationship of Polaris's elevation to latitude would be all the correlation they need to be able to successfully navigate most of Earth. They would just need their latitude, compare it to the time, and then to the expected precession of the star they were going to gauge, and then you could easily determine your direction and find your bearings almost anywhere on Earth. It occurs to me that we would not need longitude for that method of navigation at all, really. Very interesting. But let us return to the narrative and go over the tools that our ancestors used to navigate the Earth according to the stars. 3 different devices were invented to try to work out the latitude more accurately. They were the quadrant, the astrolabe, and the sextant. The quadrant was invented by an Islamic astronomer in the Middle Ages, and it could be used to calculate the angle between the observer and a star or the sun, very similar to a sextant. The sextant was actually invented in 1701 and used 2 mirrors to measure the angle of the sun at noon, or the North Star. And using these devices, a sailor could know their latitude in the ocean, although there were technical problems and the calculations were very difficult. If you know your latitude, say it's 50 north, then you know that you're on 50 north, but that ring of latitude does pass through France, Poland, Russia, Canada, and the UK. You can see how they're creating a case for knowing your longitude to be helpful. Right, you had a longitude, which city that you were in based on that. Humans have survived with latitude for centuries because it wasn't too important to know longitude. And when the area of exploration and sea trade began, it became more important. I'm going to stop right there because that's the historical interlude still that we're in. But the fact that they took a time to explain that people didn't need longitude and it wasn't important for all of history until the 1700s when it became important, that seems odd. I'm not sure why people before didn't need it, but now we do need it. But we'll have to keep going and put that on the back burner. The longitude is difficult to calculate. There are no moves from heavenly bodies to the south that you can use for navigation because the Earth rotates east to west, respectively. So, but found ether, wind, etc. from our frame of reference. And the Greek astronomer Hippocrates came up with the idea of longitude in 150 BC, and he set the 0 point as Rhodes. So that means that he denoted the meridian as the place he lived. I think as an island and called Rhodes. But really, when you have one set of coordinates already outlined, that being the latitude, which has a strict relationship with the sky, and then you want to find the perpendicular relationship for the proper grid, you would need to pick a spot, start, denote that as 0, and then equidistantly place those lines around. So in that situation, it doesn't make any difference where you place the 0 or where you start. And comparatively nowadays, they did the same, but I do think that they took special consideration in where they placed the 0, just going to say. Anyway, so they said that it wasn't important to calculate longitude until it was. You can go along with that. So there was no way to calculate your latitude when you're on a ship. The only way that they could do it was by comparing the time at the 0 point with the local time on the ship at sea. And that was impossible to do in a world without clocks. So the idea of using time to tell the location of the ship was thought up by Gemma Frisius, Dutch mathematician. But there were no clocks that could be used to do this. They did have an accurate pendulum clock invented in 1657 by Christian Huygens, but a pendulum doesn't work well on a boat due to the rocks and the waves and upsetting the pendulum's balance. If the pendulum can't swing freely, then the clock can't tell time. Coupled with that, the clock would also be affected by temperature differences, pressure, humidity, salt corrosion, and would thus be unreliable for celestially navigation. Many people thought that it would be impossible to make a clock that would work on a ship, and a lot of effort was put into a method to tell longitude by using heavenly bodies. It required incredibly complex calculations, and observing the heavenly bodies was very difficult to do from a moving ship. In the 18th century, Spain, France, and Britain all offered prizes to the person who could solve this problem. It took a long time, but finally in 1730, a clockmaker called John Harrison came up with the idea for a clock that used a spring instead of a pendulum. It took a lot of trial and error, but his clock was first tested successfully in 1736. So by using the clock, a ship could accurately work out its longitude by comparing the time on deck to the time at Greenwich, which was 0, and naval clocks were very expensive, and not so many ships could afford them. The longitude wouldn't be comprehensively used until the invention of the radio in the early 20th century. But we do discover that latitude has been vital to our ancestors over the past 100 years, even though they were able to employ its usage ubiquitously all over the world. That is to say, they relied on that relationship for very many things. They were frequently employing celestial navigation in the terms of aligning themselves to Polaris so they could tell roughly at which latitude they were at. We also discovered that there's a huge dependence and correlation these coordinate systems have had with the sky, specifically the celestial sphere, that is the grid in the sky marking and mapping the stars. Again, the grid that functions as right ascension and declination, the grid that already incorporates that as an axis as a function of time. Interesting. Latitude is actually directly related to the way that we perceive Polaris and the change in its apparent elevation with its increased distance. It seems that longitude, though, it's only been possible to calculate to the required degree of specificity very recently. It was measured and mapped out according to the sky, for sure, because they only plotted longitude lines when they were trying to geodetically survey the land, and once they made a measurement on the land, they would take a correction based on the alignment to the perpendicular celestial bodies, and they would do this by marking a transit. So they would take a point, make a measurement, look at the sky, mark out the transit, see when it transit, and then based on that transit, calculate the time on the periodicity of when it would come around again. It's a very long, roundabout way of determining longitude, but they started to do it the first time as a paper called The First Deflection of the Vertical. That's famously known for the first time they employed this method. So that means that every part of these two coordinate systems, the geoidal longitude and lat, and the celestial sphere with the right ascension and declination, both of those are inherently incorporating the way we see and also incorporating right into the way that we navigate, as well, of course, inherently incorporating sphericity. This is a pivotal observation. When you consider where these guidelines originally came from, you begin to see the interpretive framework put before us for what it is, a specific interpretive framework, or, as we are now becoming more familiar with, a specific coordinate system with which we interact with, comfortable with. As we now know, data can be translated between coordinate systems seamlessly with mathematical transforms back and forth. The relativity also says that between frames of reference or coordinate systems, all frames are equal, all systems are equal, except now we can see that we are specifically and carefully provided with a single interpretive framework or reference frame without any apparent alternative or reference frame for comparison. It says the history of the other coordinate system is hidden, as is the ubiquitous treatment of the ECEF, meaning the notorious Earth-centered, Earth-fixed reference frame. We always compare with the Earth-centered inertial frame, the ECI, in terms of satellite and GPS. We're talking about reference frames again, but it seems that they have hidden the one reference frame for GPS, the Earth-centered, Earth-fixed, and created a new reference frame, the ECI, with which they do all their calculations because it specifically negates the directional speed of light by syncing the sidereal time with the Earth spin time. So if there's no difference between the Earth spinning and the energetic background with which the light travels, then there'll be no differential speed of light, and the ECI frame negates that variation just for that one reason. Now, just to bring it back to what we were referring to, if we're given a preferred coordinate system in which to interpret the world, that being geoidal, sphericity, longitude and lat predetermined, Google Earth has it all mapped out, that's the framework with which we interact with the world every day. There is no other option that was presented that we have known that anyone has encountered. It's never been presented. Specifically, right? You have to think specifically, it has not been presented so that we all adopt the same interpretive frame of reference. But until Einstein, all people everywhere thought of themselves at the center of all things moving around them. When Einstein mathematically proved through his theory of covariance and special relativity that actually all reference frames were equal, only then were people allowed to be led into the thinking that other reference frames were not at the center but also equal relatively. The way that longitude is derived is through a complicated process through the geodesic surveys involving the corrections to the measurements, corrections to the celestial sphere, once they correct for the appropriate deflection of the vertical. So I went over that earlier, but let's just give a brief overview of what is a deflection of the vertical. It's a little complicated. I'll go through it once real quick. It comes from land surveying. When you're doing a geodesic survey, which is different than planar surveying because you're incorporating a radius, an R value over surveys over usually 100 miles, where you take measurements and you make observations, you correct those observations when you mark it, usually to lines of longitude and latitude. Because it's such an important concept in what we're about to pose, and because it's important to understand how geodetic surveying works as well, we'll go over real quick the vertical deflection that we keep talking about, which is most commonly called the deflection of the vertical in regards to surveying. So typically, they define it as the angular difference between the direction of gravity vector and the ellipsoidal normal through the same point at Earth's surface. Now, that may seem like a little complicated jargon, but the way that they define a geoid is actually relevant here. It's a shape which has a requirement that necessitates a perpendicular directional relationship to the gravity vector. Now that, again, seems a lot, but it's a geoid, which again is a sphere which determines down by radial inward tangent lines that point towards the center, determined by a radial velocity. So that's what a geoid is. So how do you know for sure which direction is down on a shape like that? That's why, definitionally, it requires a perpendicular relationship to the direction of gravity, because it has equidistal gravitational potential, right? Essentially, when you're using this shape, you have to make additional corrections when you're using it to make surveying measurements. So it goes, the deflection of the vertical at Earth's surface is computed by comparing astronomical and geodetic coordinates. It gives you this explanation of how the geoidal model intercedes with the ellipsoidal model of the two horizons, and you got to make a correction. And honestly, that doesn't make a lot of sense to me, but when you start including fantastical models back and forth with interlays, you lose the plot a little bit for sure, so we just let them figure it out. But what I think this really is the correction of the physical geoidal longitude lat system to match the celestial right ascension declination celestial sphere. Essentially, we're mapping the ground to match the sky. We're marking the ground to recede into the horizon at the same rate that Polaris does, right? The factor that we're taking from the sky to inflict on the ground is the descension rate of Polaris and its relationship to us. Like, so as you go away from Polaris to 45 degrees, it goes to 45 degrees as the angle on your horizon, right? And if you go to the equator, you'll see that it goes almost on the horizon. Its elevation is 0. So 0 elevation, 0 latitude. So they said that the deflection of the vertical and the meridian is the difference scaled for the meridional convergence between the astronomical longitude and the geodetic longitude of the same point. So again, we're taking a point, we're doing the longitude measurement that we marked on the ground, we're comparing where the corresponding longitude measurement would be on the outer celestial sphere. Because again, they're envisioning this as a sphere surrounded by another sphere of infinite radius, processing all the stars. So they're saying there's a difference between where the point A appears on the longitude of the celestial sphere above us and where it appears on the sphere that we're on right now. And they're told that they're correcting their measurement on the ground to reflect and correct the measurement to the sky. Now that was tough to get out, but that's what they're doing. That's what they're told. What they're really doing is making sure that the ground survey matches the sky, essentially, right? So we really hit home on that, I think. So in their formula, when they try to solve for this, they assume the components of the deflection as vertical, and then they have both a left and right direction or a north and south vector. They have two components that sort of have the plus and a minus as they cancel each other out to get the true value, essentially, is all that's saying. And while we're here, this is the curvature of the plumb line. So this is like the final kick in the balls to them when they actually figure out the correct position with the intersecting ellipsoidal and geoidal horizon lines. And then they find their deflection, they calculated it, they figured that out, they've accounted for it. They're still stuck with a plumb line that can't quite find level because of that geoidal shape and the necessary potential at Earth's surface and vice versa. To solve this final problem, the curvature of the plumb line between the geoid and the Earth's surface, and again, they can't observe this directly because of the presence of topography, so they must estimate how much this plumb line is curving using a model of Earth's gravity field within the topographic mass. Now, this is already to a level of ridiculous supposition and detail that everyone should be shaking their head and throwing their hands up, but they don't. They do this and they tell us that it's fine. The curvature of the plumb line can be estimated using a formula which is based on normal gravity and affects north-south deflection component only. Now, hold on, wait a second. Why would the curvature of the plumb line be corrected by a formula that only pays attention to a north-south directional vector? Where have we seen that before? That's odd. That can't be related. We'll let that go for now. And it says that the evaluation of the curvature of the plumb line is very difficult because the exact values of gravity along the plumb line can't be measured. And for the model, us to know that, the mass distribution and the topography would be known. So for us to do that, the mass distribution of the topography would have to be known, and a crude estimate of the curvature of the plumb line gets calculated and then applied. So the actual curvature is not known, and the approximations are barely useful and ignored. Anyone confused yet? In terrestrial surveying, the deflection of the vertical has three primary uses. Transformation of astronomical coordinates to geodetic coordinates. Well, they're coming right out and saying that's the goal then. All right. Conversion of astronomical azimuth to geodetic azimuth. Again, that's the goal for sure. Finally, the reduction of the vertical and horizontal angles to the spheroid. That just seems that if you keep this up, then the deflection angle will ultimately be the same, and you'll remove the difference in the first place once you correct all the land masses to make sure all the land points on the longitude line to match the celestial longitude line. They go on to say that when they have this coordinate system transformed and observed with respect to the gravity vector, again, that downward directional relationship to gravity, when they rearrange it, they get an astronomic coordinate set, which is measured. So where the deflections refer to the surface of Earth, the point at which astronomic coordinates are measured. So if the deflections of the vertical are the geoid, then the limit is disposed and the curvature of the plumb line should be acknowledged. So vertical angles have to be corrected for at Earth's surface for the same reason as horizontals to them. So the skew, they know skew normal corrections and they figure it out. So in the case of a single measured zenith angle, the component of a deflection of the vertical would be, it would have a deflection of the vertical in one direction and a zenith reflection in the other. They'd add the sum of those two with respect to the ellipsoidal geoid as we see, and that's the correction that they would apply. The reciprocal trigonometric leveling. A large proportion of the vertical deflection cancels on differencing. They're doing a lot of mathematical balancing here to an equation that we don't have to pay attention to for models that they're trying to force on the planar measurements that they're measuring in the first place. Notice that they said you can always apply these corrections, especially when you have long baselines. And again, that's funny because you only find spherical excess when the triangles are sufficiently big, because they hide that in the correction of the correction angles that they apply when they turn those planar measurements into a ball via the application of correction angles over long distances. So the same tricks are being employed over here, it seems. We also learned that every single aspect of the coordinate system and the sky was backwards engineered from the flat plane and then made to seem exclusive to the globe, depriving us of that literal relationship. Very odd, and what a dirty trick. So the next time someone says, hey, but the globe model matches the sky, you can mock them for their absurdity with the rest of us, and you can throw in a statement that, oh, so you assumed an R value, you measured an assumed R value, you compared the measurement to the assumed R value, confirming the R value. That's a little undiluted, right? So essentially, if you look into this, you'll find that everything on Earth, the longitude, the latitude, the systems that we have, the markers, they're all based on the sky. We only know our position on the Earth because of the sky. That is a crazy thing to understand and say, but it's true. Look at how they determined latitude. They looked at Polaris and the sun. Look at how they determined longitude. They looked at their first markers and then made observations to other celestial bodies that they could see, took times like transits, and then plotted the time on the sidereal rotation to figure out where on that cyclical pattern they would next see that star, and then be able to determine the longitude that way. Why is every marker on the ground based on the sky? Why were they so determined to line up our geodetic longitude lat spheroid with the celestial spheroid? Why? I wonder. When they were discovering transits and planning their deflection, they were trying to geodetically survey a portion of the world, but what they were really doing is adhering the physical world to the celestial sphere. So we're forming a latitude, a longitude system on Earth, and we're making sure that it aligns with the only source of motion we've ever seen or detected, the sky circling above us. So we've made sure that the markers on the ground directly match those in the sky. Great. To touch briefly again on the significance of measuring the deflection of the longitude. So I read a paper, it's called the deflection of the first vertical, essentially the first time that they went to go do this, and what they found was they could actually align their geoidal measurements to the celestial sphere. So that paper was the first time anyone had tried to do that, apparently. It was challenging, and now that it's an astronomic geodetic measurement, they couldn't really do that going forward. They've essentially made those two terms synonymous, astronomic and geodetic. They are synonymous because they're related and paired. An astronomic geodetic measurement would be something that comports with the sky and the Earth. Following? Whether you take the longitude from a geoid or the right ascension and declination of the celestial sphere, you'll end up on the same point in reality. And that's the whole point, I think, right? We denoted that they backwards engineered the observation of celestial heavens and the relationship of Polaris to the elevation that you see it on, and they denoted that relationship in the northern hemisphere, and they denoted that as the basis for their model, right? They said that you could only observe that because the surface of the Earth is curving underneath you as you get away from it. And they literally made sure that the ground would curve with the lines that match the sky and the arc of your horizon. So they took that 69 miles per degree factor, that factorial, that scaling covariant, and they used that to project the surface of the ground out beyond where you could see, and told you that it was forever curving down perpetually. So they told you that for every inch you can't see past, for all the area that you can't see around you, that's where all the curve is. It always starts to curve beyond the edge of your vision wherever you are. That's what they had to tell us, because we could never see it, find it, or measure it. Here we are. So again, the whole point was to match the celestial sphere with the geoidal sphere. Essentially, the longitude and lat system of Earth are synced and matched to the parade and procession of the celestial bodies, which is the only true marker anyone on Earth has to tell us where we are. Isn't that amazing? Let's pay close attention to the math here, where we're going to be paying attention to the metric by which we scale everything. So again, covariant scaling means that we're proportionately increasing the size of all the components so the relative scaling size of the system itself would scale appropriately. So that means that you're not going to increase a component in a bigger ratio than any other component But essentially, that's what they do with these measurements. So they take a basis and they take elevation angle to Polaris, 3959. From that elevation angle, they built a scaled covariantly model of everything in the universe based on that distance scaling, factorially perfect with fractals and everything, right? They scaled the coordinate system based on the predetermined spheroidal model. They aligned it with the sky. They literally made the ground curve at that rate, at the rate which matches 69 miles per degree. So they made the ground curve at the rate of your arc of horizon right away. And that's where that relationship comes from, of course, 69 miles per degree. We have to bring that back up. So the astronomical ephemeris for the year 1776 went over that, but it does include a special note during this year, the 1776, in regard to latitude. They had specifically put out a request to ask people to assist them with the determination of latitudes at sea at that level, because they were having notorious issues with it. And apparently that they were having so many issues that people were coming in. All right, so we know that they observed a relationship between elevation of Polaris and latitude. We know that they've used that relationship, converted it to a metric, and then used that metric to produce a covariantly scaled world with everything sized correct to the factorial. Right? It doesn't matter what size it is, as long as the proportionate size lines up back with the original observation. Probably the best way to say it. But knowing this, when we see things like Walter Bisland's model, when he questions how the azimuthal grid of vision would know its latitude, isn't it funny that he has not yet pierced the absolute fundamental portion of the globe that connects it to the model at all? He has no idea. Elevation to Polaris is literally the latitude. That's how it was derived. So it's a funny question for him to ask. So the whole model for the globe is built upon the relationship between Polaris and its elevation angle in the northern hemisphere. What do they need once they realize that? Then they would need longitude. How would they get longitude after being provided so well prepared and clearly proportioned latitude? Well, again, that's where the deflection of the vertical comes in. This was a specific error that they only got when trying to map the perpendicular lines of longitude. We could even say that the deflection of the vertical could be a particular correction when you specifically have to align geodetic and astrodetic or astronomical coordinates, when you're supposedly aligning a point in the sky with a point in the ground. And so if the sky is curving around you and the ground is flat, what would you do to conform with those requirements? Interesting. Typical deflection of the vertical is the relationship of the angle between it and the star. But when we take a look, we actually know that it has a north-south component and an east-west component that is treated differently. Of course, we just went over that. It's the difference between the astronomic latitude and the point on the celestial sphere, and then the geodetic latitude, where the point on the Earth. Those two differences is what results in the deflection of the vertical. Now, could it be possible that they're really just correcting geodetic and astronomic measurements to make one equal the other and telling people a story about a geodetic diadem, including a perpendicular intersection of a geodal and ellipsoid model? Could be, but we're not going to sell that to anyone, so let's move on for a minute. We could also mention that all the horizons they have to invent before they even start looking at the sky, if they can figure out where they are from not being able to determine down, etc. But they are just projecting the celestial sphere onto the Earth at the rate in which the bending of light would recede as you approach Polaris. So again, hammering it home. They observed a relationship, they took that relationship, and they forced the components of that relationship into the physical reality that we inhabit. They can determine the geographical longitude can be deduced from the meridian transit time of stars. Remember when I said the first deflection of the vertical, when they looked at the transit and were able to coincide, they made that first correlation, and then they began correlating the maps since then. They take the difference between when the transit is, because they know the latitude, and then they figure out where Polaris is, and with the time and a clock, they can predict where it will next come around, and using those two factors, they're able to accurately correct for longitude. Allegedly. They call it a deflection, make the correction, and move on. Let's watch a quick video showing the equivocation of Kepler's law and Newton's law, and then we can see how the other things we talked about will all come together for the final conclusion. All right, and just to wrap it up and tie it all together here, we're going to go quickly into Kepler's law and Newton's law and the equivocation between the two, since they're both, now we know, derived from optics, which we then conclude distances from, and we should know that essentially now all the distances on the Earth have been computed with the stars in mind, right? Because we're going to mark limits and delimiters with our latitude lines, which we've already denoted from
the elevation angle to Polaris, and then we've also now added the other delineation perpendicularly for the longitude, which we figured out by trying to do geodetic surveying and then comparing those skewed results to the stars to align them back to the stars. Everything that we use to measure now is good and effectively curved at the rate at which Polaris declines on your horizon with distance. Everyone good? We can move right into this video, and then we can tie it into the ultimate conclusion.
Did you know Kepler's third law says that the square of the period of the planets is proportional to the cube of the radius? This was discovered almost 400 years ago. It is not well known that you can actually derive Kepler's third law from Newton's law, the force of gravity on any planet. When a heliocentrist claims they know the mass of solar bodies, this is how they calculated it. This mass of the planet times its radius times its angular velocity squared. The angle of velocity is 2 pi over t, where t is the period. So you can derive Kepler's law from Newton's law, but notice that the mass of the planet disappears. It cancels out. And this is characteristic of when you have something that is kinematic, something that depends only on empirical observation and doesn't depend on a law of physics. Deriving orbits with Kepler's laws and Newton's constants turns out to be physically meaningless kinematic equations after all. G and M give you a proportionality to the periodicity of the observation, meaning these equations don't actually account for mass attracting mass at all, at least not in any meaningful way like we've been led to believe. It was just a kinematic equivalence with no physical meaning used to convince the masses of the power of scientism. It was derived using basic observations of the celestial bodies and uses a form of scale invariance to proportionately scale the rest of the universe from a single stellar observation. One can observe, say, that the angular size of the sun and moon is approximately 31 or 32 arc minutes, which is 0.53 degrees. You can then use this angular size to tell people that the sun is 93 million miles away and 864,337 miles wide. However, they would not be aware that the same observation also works for a sun that is 229 million miles away and 2 million miles wide. Using scale invariance, the same observation could also work for a sun that is 46,701,000 miles away and 432,000 miles wide. Do you see the trick?
So for the last bit, we'll just have to quickly go over stellar parallax, where they take an apparent displacement of an object due to the real displacement of the user, and they say that the direction of the object is referenced to the latter. That's a really dumb way to explain it. So it's a change of the apparent position of an object relative to more distant object, caused by a change in the observer's line of sight. So essentially, they're saying that they can measure an angle of an object that's different when it's at each end of its elliptical side. So the further away from it you get, that's not it at all. Let's go over stellar parallax again real quick. And it's again that apparent shift in position relative to the other stars. So they claim that it happens all the time and that it can only happen on a heliocentric world, of course. They had this exaggerated motion, what it would look like 10,000 times exaggerated for 3 to 5 years. It would make this motion exaggerated to show you what it is because it's never been seen and only been measured in increments low enough for no one to care about it. So it's a combination of, it's an apparent shift caused by Earth's yearly motion around the sun, proper motion, which results from the star's true motion through the galaxy. They say proper motion and parallax motion have been exaggerated here. So again, they're assuming that is the difference between Earth's orbital velocity and the velocity that the object is under itself. Right? So we're saying that none of those things are under velocity, that the stars are rotating around us and that they look slightly different when they rotate from the right to left as they do from left to right. So we have to go back into stellar parallax real quick. And again, just a brief summary of what that is. It's when they take an angle to a star and they notice that the angle has displaced relative to the star and the other stars behind it, right? So they're assuming that the stars are in motion around us and that the Earth is in motion around the sun. And they're assuming that this observation of parallax, this different angle, that is a result of those two motions and forces, right? And again, for us, with only the stars moving, it would actually look the same. If the stars are moving over us, it would look different, slightly different when it was moving right to left as it would left to right. Anyway, the problem with a covariantly scaled universe built off factorials that are based off an optical observation that is true is that once you start making these great bounds and leaps of assertions and creating units based on other units and then distances based on other distances, then you run the risk of this whole thing deflating, and that's what we're going to do right now. So they estimate stellar distances using the parallax, which again is based off an angle that may or may not change because they've already adjusted the geodal to the celestial sphere, don't forget. So they're estimating distances from parallax. So they notice that the distance is X, they make adjustments, they determine this, right? So this is from a different paper about inverting a parallax. So when the parallax isn't substantial enough to compute a distance, they simply take the inverse and do the same. And they do a reciprocal zenith angle parallax, essentially, to get the measurement that they're looking for. So, never going to stop a glober. If the math don't show it, they'll just make new math. Just kidding, slightly, but essentially the existence of negative parallax not only refutes this argument, but definitively proves that the Earth is not in motion and the stars are in motion. Geocentric explanation of parallax, it works exactly the same with the inverse angle, so there's no need to even try to talk about it, of course, unless that it proves the Earth is stationary, then we won't. But essentially, here's a graph of negative parallax that says when you're computing distances and creating covariant scaling units based off this observation, if you have a negative observation, how does that affect your invariantly scaled units that you've created? Does everything go in half? Do you just half of them cut out? It's goofy a problem because that's obviously, you can't have that, right? So a couple examples that negative parallax definitely exists. It's something like 42% of the all observations. And again, from our position, if all the stars are rotating around us, and some appear to go one way and some appear to go the other, that's a problem for that observation proving uniform Earth motion, but not a problem when they're rotating around the Earth from the left and from the right. Essentially, negative parallax refutes their claim of parallax proving motion, and also negates all the distance scaling that they created covariantly off the single observation of that stellar unit. So again, they took, say, the sun of the angular resolution, and they saw that they could say that the mass of the sun and the distance of the sun were any number of covariantly scaled pairs, and they could change it at will and move it back and forth. And they took that factorial and they applied it to the whole universe. So they scaled other planets, other distances, other solar systems, distances between solar systems, the relative size of one planet's moon to its base. All of that are results of the factorial scaling covariant scaling program based upon an actual optical observation of the size of the sun or any object. That's what it's based on. And again, this is all coming from geodetic surveying, making observations optically, and then adjusting those terrestrial geoidal observations with a celestial component. And again, the best way to think about it is deflection of the vertical is the comparison of the geoidal longitude and the celestial longitude at the same point. So any variation in the sky and the ground, and then the reflection would indicate that inverse, right? Just a quick stop at the kinematic equivalence between Newton's laws and Kepler's law. And again, Kepler's law were purely empirical when stated has no theoretical backing. Kepler drew all the conclusions from data gathered from the naked eye, and probably primarily from Tycho Brahe from 1546 to 1601. So his laws were observational. The biggest question was, do they conform with the new Newtonian gravitational interactions? So this is the derivation of the breakdown for the composition of the two. When you derive one from the other, the algebraic equation cancels out the mass. That's the important part we want to pay attention to. Again, this is telling you that this is how they calculate the mass of all cosmic objects. They use this all day long to solve for it. But if the kinematic equivalence actually drops off the mass as a kinematic proportion, then we can't really say that it's mass attracting mass as the primary focus of this interaction. Now, can we? Well, that is interesting. If the mass cancels out, it has no physical meaning, and it is like literally meaningless. So it is all optics based. That has nothing to do with Newtonian gravity, why all the things in the sky do what they do. The particular question here is, hey, how does Jupiter's moon orbit as Jupiter so perfectly following Newtonian gravitational mechanics? And you're like, it's not. They backwards derived the kinematic equivalent of Newtonian from Kepler. They said that actually it's because of this mass, that's what's happening, and that he never provided the dynamic solution. It was another kinematic equivalent that they tricked everyone into accepting as a dynamic explanation, essentially. So here we go, just looking at the covariant scaling factor. So this is how they take one measurement and scale it to the whole universe, right? So they take the proportionate measurement of the metric and they apply it evenly to all the components so that the system scales covariantly independently fine. Here is the breakdown of how the math shows that the m's and the mass cancels out. So it starts off on the top, from solving the algebra equation, and then you end up with this as the refined, derived Kepler's law. Interesting. That they were observational and had no backing in material matter. Again, that's just a component of the kinematic equivalence between geocentricity and heliocentricity. Again, the integral factor was they had to make people aware of that equivalence. They had to manufacture that equivalence and then get people comfortable in removing their inverted reference frame before they'd start envisioning themselves at anywhere but the center of the universe. And just gonna move on quickly to show that, of course, everyone knows that it has been determined that this can be mathematically derived, and they will claim that, no, it doesn't mean the mass is worthless, but we do know that kinematically they have no relevance if they can be removed from the equation. That's the importance of what we're talking about when we figured out that they have mapped the Earth to the sky in the form of comporting and astronomical lines of latitude and longitude all over, so they can correspond and relate to one to the other. Then they can take tools like an observation of a particular angular resolution, and they can scale that object's mass and distance proportionately with the covariant scaling factor to any which distance they want. They can literally take it and drag it, and the whole universe scales or shrinks as they take that slider. Is everyone following now? They've created a fantasy world based on nothing but observations and told you that they've proved it and conformed it with mathematical equations beyond your understanding that have definitely confirmed everything we've said. That's where we're at. Hopefully we can take some steps forward, take some understanding from what we've gleaned today, and progress our position and argument further. Thanks everyone for taking the time. Just to close it out with the final summary and correctly interpolate and draw all the conclusions that we want to make. So this whole exercise has been a good example of dynamics versus kinematics, right? We always know that there's kinematic relationships and derivations between principles and concepts, and kinematics describing the actual motion measurement. And there's different ways you can describe that motion that always derives from the other and remain within the same covariant scaling factor pool. Then you have dynamics, which is that same motion, but making predictions in the real world with real forces and real variables, and making predictions on that motion and how that motion will work. So they told us that Newton's law of gravitation was a dynamic force, that it was actually how things worked in reality. That's why we had to follow it. And it turns out that is absolutely not the case, because we can derive this same thing we can derive Newton from Kepler, so that the mass that he said was pivotal actually cancels out algebraically and becomes physically meaningless or kinematically equivalent with no real world meaning. What we've discovered is they lied to us about the meaning of mass and the mass attracting mass proponent, and they did this by effectively aligning the geoidal longitude and latitude with the celestial sphere, and then ensuring that the geodetic coordinates would curve at the rate at Polaris descends from you. So literally the curvature of the celestial sphere is manifest in the Earth because of how they mapped out the longitude lines. Once they had that in place, they took an observation of 0.53 degrees or arcseconds, and they said that because you see it at that size, they can tell you that it actually is this far away and this big. And they started building. They built the sun, the moon, the other stars. They told you how big they were, how far away they were. If you've noticed the times when they made adjustments to these changes, they changed everything. An adjustment to the distance to the sun would necessitate all the other proportionately scaled distances changing. And if you notice, when they change something, they do end up changing a lot of things. It's like dragging a sliding bar across your system, and everything scales proportionally. So we had to understand all of this to see that they lied to us using the metric of measurement of optics, and then covariantly scaled, which was a kinematically derived mathematical equivalency, dropped a little lie about the meaning of that mathematical equivalency, told us it had real world meaning, then proceeded to build a solar system all around us of things they could not prove, and then a system of solar systems around there of other things they couldn't prove, and then galaxies around those systems of other things they couldn't prove, all pulling down based on an optical observation of the heavens that Kepler made 400 years ago. Guys, everyone needs to wake up.